next graph choice that we're looking at is the circle graph. And the circle graph has some key features that are different from a bar graph and a line graph and purpose for using them. So a circle graph is going to show you parts of a whole. Okay, so you'll have a whole, let's say, category, and what are the parts within that category. The entire circle graph represents 100% of the data. So whatever information you get. For an example, in ours, if we pull together the category of somebody's favorite music type, that's the whole is favorite music, and it can have different parts of the whole. So out of the whole amount of people, what part liked this amount? What part liked rap? What part likes hip hop? What part likes rock? What part likes pop? Okay? So 100% of the data, the entire circle graph represents 100% of the data, and each sector, we're going to use this word, sector, represents a percent of the total. So that's what I was saying. You have a circle, maybe these are all the people who have a favorite type of music. So it will be broken up into different sectors based on who likes what kind of music. All right, so this may be one kind of music, this is another, this is a third, and that's how that can be represented. All right, circle graphs are good for comparing each category. Sorry, I wrote pretty long on that. I don't know if I gave you enough space. Comparing each category. And when you compare, you can kind of visually see if one part is larger than another part. You can pick that up very easily without having to look at the numbers. So comparing each category of data to the whole set. So how does it compare not only to each other, but in comparison to the whole? So a circle graph shows parts of a whole. The entire circle represents 100% of the data, and each sector, or part in here, represents a percent of the whole total. Circle graphs are good for comparing each category. Remember, the bar graphs were good at comparing the different categories, but circle graphs are good at taking each one of those categories and comparing the parts inside that category. Line graphs, remember, are good for things that change over time. All right? And so that's that one. Let's look at how these look here in an example. Use the graph to answer the question. So it looks here we have a punch recipe. So somebody's going to a party, they're making a big bowl of punch, and what they're putting in this punch for you. So it looks like half of it is ginger ale, 25% of it is orange juice, pineapple juice is 12.5%, sherbet is 12.5%, and lemon is whatever is left over. So which ingredients are present in equal amounts? Well, equal amounts, oh, this is lemon sherbet. I was like sherbet and then I called it lemon, and I was thinking that's weird, I only see two parts there. I didn't even know they made lemon sherbet. That's funny. So if this has 12.5% and that has 12.5%, they gave us the numbers. We already know that the lemon sherbet and the pineapple juice, I'm just going to write pineapple, are the same because they both have 12.5%. Now if they did not give you the numbers, you would be actually looking for the ones that look like they're identical in size value. Obviously this is half of it over here. This is a large chunk of it, a quarter of it. These two look about the same in shape and form, okay? Like the measure of these would be bigger, would be the same. Sometimes that's what you have to look for. Okay. This one is going to require a little bit of math, and oftentimes when you're comparing something to a whole, you're going to have to come up with a ratio. So it says use the graph to determine what percent, so we're looking for a percent answer, of the fruit salad is cantaloupe. So in a bowl, we have fruit salad. Here's my fruit salad, okay? It's full of different fruits. It's got kiwi, blueberry, banana, strawberry, and cantaloupe. And so they're asking us, of everything in the bowl, of the whole thing, this is how much is there of each. There's 2.5 cups of cantaloupe, 2 cups of strawberries, 2 cups of bananas, 1 cup of blueberries, and half a cup of kiwi. So they want to know what percent, so what amount of this fruit salad is actually cantaloupe. So what you want to do is you want to find the cups of cantaloupe. So we have 2.5 cups of cantaloupe. And you want to divide that into the whole. So here's how you would want to set this up. So we're going to use 2.5 as a decimal. So I'm going to put 2.5. So 2.5 cups out of all the cups. So when you say it'll be the part over the whole. And when you say over, or I like to use this word out of, means divide. All right, so how much divided by the whole? All right, so the trick on these is what is the whole? Well, you can't just say 2.5 out of 2 or out of 2.5. They didn't tell us how many cups altogether there are of fruit. So I have to come up with that number on my own. So if I know I have 2.5 cups of cantaloupe, 2 cups of strawberries, 2 cups of bananas, 1 cup of blueberries, and half a cup of kiwi. I have to put all of those together because all of those together make the whole salad. So 5 and 5, that's 0. For the 1, that's 2, 4, 6, 8. So there's literally 8 cups of fruit in here. Different kinds of fruit, the whole. But 2.5 of those 8, 2.5 cups out of those 8 are cantaloupe. So we literally just do the math. 2.5 divided by 8. So that, I'll tell you right now, comes to 0.3125. 3125. So normally you're going to get a decimal answer anytime you divide fractions here. You divide your fraction to get a decimal, and from the decimal, move the decimal point to get a percent. So I'll go 1, 2, 2 spots over to the right. So I moved my decimal here to 31.2, and now I'll put a percent on it. You could call it 31% is a perfectly fine answer for me. If you were on a test, it may say 31, it may say 31.2, it may say 31.3. It all depends what they're asking, how they want you to round it, and what they're looking for to see if you know how to do. All right, but whenever you have parts of a whole, this is very, very common to say what percent of the pizza was eaten, or a school had a school lunch. There was pizza, there was chicken patty sandwiches, there was peanut butter and jelly sandwiches. What percent of students had, or what percent of the school lunches sold were peanut butter and jelly sandwiches? Well, first you have to know how many were sold, then how many of the one, and you're going to have to divide out a part out of the whole. Okay? And your very last slide here, very simple. You might know this already. The sections of a circle graph are called. This was mentioned earlier on slide 1. So each one of these sections, I'm going to make like this. A section like this is called a sector. So it's not a section, it's a sector. That's important vocabulary to know with circles, and that will be on your final exam.